Here we go, full throttle. All the instruments look fine. Till it gets about 60, we'll lift it off. Let's go over to the Hot Springs Mountains, about 30 miles to the west of here, and see some geology that's been in action and is still in action. We live on a fission reactor. That volcanic hill over there to the left is the result of fission. Later, it became an island in Pleistocene Lake Lahontan. You can see some shorelines on it. I'm not looking at shorelines right now. I'm scanning the horizon above and below for any traffic that could be in the pattern. Okay, let's go over to Hazen, where we can see Black Butte from here if you were looking out the window, about 30 miles over there. A rear view. The H for Hazen painted on the hill. These letters were originally painted on the hill for the 1920s air mile route that passed over Hazen. Black Butte coming into view. The Hazen horse image that you can see coming down the highway. The nuclear fusion reactor power, normally called solar power. And right next to that is the Earth's fission-powered steam plants. The fission power deep below the mantle of the Earth that keeps everything boiling and makes life possible. It's all natural. 30 miles away you can see Black Butte. It's quite prominent when you're driving down the highway. From Fallon you can see it 30 miles, and from Fernley you can see it 30 miles. And the length of the Hot Springs Mountains starts to stretch out to the left. The Hot Springs Mountains stretch out for about 20 miles. Driving down Interstate 80, you see the Hot Springs Mountains across the Fernley Sink in the far distance from the freeway. The only place where the motorist sees the Hot Springs Mountains close up is on Highway 50, where it goes by Black Butte in Hazen. Otherwise, it's pretty remote and inaccessible. Here's a closer look at Black Butte from a clip from an earlier video where I was explaining the lake levels of ancient Lake Lahontan. Okay, let's turn into this end of the Hot Springs Mountains right over Hazen, Black Butte. We're going to run the length of the Hot Springs Mountains. The 1902 realignment of the Southern Pacific Railroad runs around the base. The dot shows a lahar volcanic mud and breccia flow coming out. My geologic map shows a fault running between the Big Butte and the Little Butte. So often when you see these kind of splits, you're looking at a fault. The white stuff you see scattered all over the place here is diatomaceous earth, or diatomite. Diatomite is a late Miocene deposit from about 11 million years to 5 million years ago. It formed in lakes between active volcanoes. Diatomite is a sedimentary rock or shale that consists of diatoms, single-celled freshwater algae that consist of silica. The shale is so soft you can break it in your hands. It's rather like chalk. It has many important industrial and agricultural uses. It is used as filtration media, abrasives like for toothpaste and polishes. It's a very good absorbent. You can spread it on your floor when you spill motor oil. It's also a good mechanical insecticide. You can spread it under your flowers and it will get rid of the bugs. They don't like walking in it or breathing it. Something that struck me when I first saw this is the two parallel ridges. My geologic map indicated a fault zone through here. These ridges are clearly spreading apart almost the whole length of this mountain range. These ridges characterize the main tectonic force acting on the Great Basin, which is crustal extension. A look at a Nevada map shows north-south trending basin and ranges. The map looks like a corrugated surface with 200 valleys within the state. Geologic research has revealed that this started 40 million years ago and has resulted in a 100% extension. The straight-line distance across the Great Basin from the Sierra Nevadas on the California border to the Wasatch Mountains in Utah is about 450 miles. So a 100% extension means that the distance used to be 225 miles at the start of this extension. We are flying in the troposphere, looking down at the lithosphere. The lithosphere, the solid rock that we walk on, is about 60 miles deep on the average. In this region, the crust, due to extension, is much thinner. So we have lots of hot spots that have been recorded by aerial surveys. And we get more fault zones and cracks where hydrothermal springs emerge. That's a peculiar feature over there. It looks like the whole side of the mountain has collapsed, exposing a big deposit of diatomaceous shale. The fault zone continues through the center of the mountain. It looks like bake lasagna with all of the volcanic flows and breccias emerging from the sand. The sand blows over from the left side, over on the west from the Fernley Sink. And whenever time you get a big storm, it comes up here and kind of like a airplane wing, it loses pressure and it drops the sand right between the ridges. Sometimes we get intense sandstorms in this area that resemble the haboobs of North Africa. It actually can shut down the highways. One time I was dumb enough to take Highway 95 over to the right side of this mountain, trying to avoid the dust storms that closed the other highway, and I got trapped, and I spent almost the whole night parked on the highway. I couldn't see forward or rearward more than 20 feet. You had to keep going because you thought, well, somebody's going to rear end you. For years, flying on the leeward side of this mountain during a windstorm has taught me to expect intense gusts. Sometimes these gusts would hit you, and it sounded like somebody was hitting the fuselage with a 2x4. An odd feature down there. Perhaps a fault zone is disturbed, a wide swath of ground. There's a lot of shifting sand down there today. It's quite windy and gusty, that's why we're rocking back and forth. Approaching Desert Peak, we start to see the Desert Peak thermal plant. In the last few years, all of these plants have put in solar panels. It makes sense. The Brady Springs plant is off to the left down in the valley next to Interstate 80, almost directly across from this. That road pretty much follows the fault zone right through the crease in the mountains. Last time I drove that road, it was in pretty good shape. It was good enough for an SUV. Over on the left, that colorful area looks like hydrothermically altered rock. And indeed, there were a number of mines there. On the right is a vast zone of lava flows and lava breccia. It's almost, when you drive, I've driven through there and it's like a badland. This looks pretty barren down there, but I've been surprised to see quite a bit of wildlife. One time I saw a huge herd of burros, of all things, and they're not very common around here. I've seen fox families, desert foxes, staring out of their burrows at me as I pass. Over on the left side of the Hot Springs Mountains, I have seen herds of antelope running through. Now we're coming to the end of the Hot Springs Mountains, and you can see ahead on the right is the Carson Sink. Right under the wheel is the Humboldt Sink, and a little below that is the White Plains area. Cinnabar Hill. Cinnabar is the ore that produces mercury. It's a very pretty, bright ore, but you should not handle it with your hands so much, and you should wash your hands and be careful. It's mercury. Below the right wheel is the site of Paran Station. It was the lowest point in the Salt Lake Division of the Southern Pacific Railroad. During steam days, they hauled water out here all the way from Sparks, Nevada, 50 miles away. The West Humboldt Range is right ahead, and far over there is Lovelock. You can see some of the shorelines from Pleistocene Lake Lahontan. The pass where the California Trail climbed up off of White Plains to come up to Brady's Hot Springs nowadays, which was then called Boiling Springs. That white patch is Fernley Sink. It is thought by some geologists that the Truckee River actually went on this side of the mountain at one time. Now it runs on the other side of the Truckee Range towards Pyramid Lake now. Heading back in the direction of Hazen and Black Butte. We are now on the 1920s airmail and airline route. A little beyond that solar panels, there was a beacon there to guide you through here at night. And then down at the end of the Fernley Sink, that white area was the Fernley Intermediate Landing Field, which served as an emergency field. You could actually land there, but there was also a beacon. Then a little beyond that was a acetylene beacon at Fernley, which still exists, which guided you down the Truckee River Canyon into Reno. On The left side of this mountain is the Carson route on the California Trail, and on the right side is the Truckee route. There were two 40-mile deserts. The Donner Party took the Truckee route on the right, and we know what happened to them. The Carson route on the left turned out to be more popular, but both routes were plenty dangerous on the 40-mile stretch here. The original transcontinental railroad, the Central Pacific, was over on the right side of the mountain, and that was the thin thread for about 30 years that connected the nation together. In 1902, the Southern Pacific realigned the railroad over to the left side on the Carson stretch of the 40-mile desert. It was longer but had a much flatter grade. So ends our tour of the mysterious, little-known mountains between two sides of civilization and history.